No question on section 7.
For 21, for 7.2, it's on page 370.
What does it say?
Sorry,
What's the question? What is the problem?
how hard is therefore needed to estimate the population need for the amount of money a person spends at Christmas presents $2 and can be 95% confident. The standard deviation of the population is $7.50.
So you are asked to find a minimum sample size. You are given the standard deviation, and you are given the margin of error. So what did you do? Could you do anything? Did you know what to do?
Yeah, I did something. I just don't think it's correct.
Okay.
That's what I did, but I didn't.
Why did you put square root here?
I don't know. I think that was maybe I read the formula wrong.
Is 2.
So I don't need the square root of it.
No.
Okay. Okay, let me try that.
Any other question? So when the standard deviation of the population is unknown, we use the sample standard deviation and the t-distribution to find the margin of error. That's what we did last time. And we should know how to read you should practice with homework how to read the T alpha over 2. Now we want to look at the confidence interval for proportion. So the sample proportion is p hat. If x is the number of success, and n is the sample size or number of trial, then the sample proportion is p hat equal to x over n. And the sample proportion of failure is q hat equal to n minus x over n. So if x is greater than or equal to 5 and n minus x is greater than or equal to 5, we can use the Z distribution. We can use the Z distribution to compute the confidence interval for the proportion. As we have been doing, we want to know the margin of error. We can use the Z distribution to compute the margin of error, which is E equal to Z alpha over 2 and square root of E hat over part N. The confidence interval for proportion will be confidence interval E hat minus E less than or equal to P less than or equal to E hat is E. Let's look at this example. A sample of 500 nursing applications includes 60 from men and from men. Find a 90% confidence interval for the true proportion of men who apply to do nursing. So here we are told that a random sample of 500 applicants are selected and 60 of them are men. So what is the sample proportion? What is N? What is the sample size? 500. What is the number of success? 60. So you have this type of quotients that you have quizzes. Find the sample proportion. 60. Which is 6 over 50. Can you use your calculator to find this? This is the sample proportion. That is about 12% of applicants for nursing are male. This is a point estimate. So we want to find the 90% confidence interval. If the confidence level is 0.9, Z alpha over 2, 1.65. So E will be 1.65 times square root of 0.12. Then Q hat is 1 minus is 540. I'm sorry, 440 over 500, which will be 0.8 divided by 5. So we will get this to be 0.0 using your calculator. So the confidence interval will be 0.12 minus 0.024. 12 plus 0.0. So they give us 0.096. So the true proportion of male applicants for nursing is between 9.6 and 14.4%. The margin of error of 2.4% if you want to express it in percentage. When we are dealing with proportion, we can also consider the minimum sample size. So as simple as that, finding P hat and Q hat using the information from the sample and use it to compute the margin of error. Minimum sample size for proportion. The minimum sample size for proportion is, when we do that, we have there are two conditions. If an estimate for P, the population proportion or probability of success, is provided, then N equals to PQ Z alpha over 2 square. If no estimate for P is provided, use P equals to half and N equals to 1 over 4, which is P times Q. If P equals to half, Q equals to half, and Z alpha over 2. So to determine the minimum sample size for proportion, we have two cases. The first one is if from past experience, we have an estimate of the proportion, or we may not have an estimate of a proportion. And in that case, just assume it's half. Looking at this example, the researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size. So this researcher wants to determine the proportion of people that own a home computer. But he does not want to be wrong by more than 2%. He learned that in the past, it was 40% of people that had a home computer. And he wants to use that to determine the minimum sample size we can use. So for example, now that we are in the election period, those who are doing polls sometimes need to determine the minimum sample size to be accurate. It's frustrating that after all your work in polls, you go wrong. What is the minimum sample size? Most of the time people feel like you did not take a large enough sample. for 100 million people that went to vote. You took 100 people. That is too small to give you a good proportion, a good point estimate. So you might say a good point estimate should be what? If you project that the proportion will be 50% and it happened to be 60%, somebody might say that your work was not good. So you want to determine the minimum, you want to reduce the margin of error so as to be able to project in a more reliable proportion. So here you start with a maximum error of estimate. What is the maximum error of estimate here? It is, maximum is 2%. It does not want to be wrong by more than 2%. And an estimate for P is 0.4 and Q will be 0.6. C is 95%. And for this C, Z alpha over 2 is 1.96. So N will be 0.4 times 0.6 times 0.02 Z alpha over 1.96 square. Use your calculator to do this. It is 23. And 96. We round it up to 23. This is the minimum sample size you should use. If you want to project the proportion, you should interview at least 2,305 people, sure that you are not going to go wrong by more than 2%. And we should know that sample size is not the only factor that guarantees a good estimation. Sampling techniques is a very, very important factor in making estimation. Now, the same researcher wishes to estimate the proportion of executives who own a car phone. She wants to be 90% confident and be accurate within 5% of the true proportion. Find a minimum sample size. In this example, E equals to 0.05. There is no estimate for P. No estimate for P. So choose E equals to 1 over 2. Q equals to 1 over 2. C equals to 0.9. Z alpha over 2 equals to 1.65. So N will be 1 over 4, 1.65. So we have 200. So for him to be accurate in his estimation of the proportion of individuals who own a computer and not be wrong by more than 5%, he should interview at least 273 people. Now we are going to look at another type of estimation, estimating the population variance. We have observed here that sometimes the population variance is unknown. So we want to look at how to estimate the population variance. So the distribution that is used to estimate the variance is called the chi-square distribution. This is a random variable which depends on degree of freedom, like the t distribution. Generally, my PowerPoint have too much information. Sometimes I want to summarize it. Confidence interval for variance and standard deviation. The chi-square distribution. The chi-square distribution is something like this. Called chi-square distribution. The chi-square distribution is a family of curves that depend on degrees of freedom. It's a non-negative random variable. Chi-square is a non-negative, that is, it doesn't take negative values. Random variable, which is skewed to the right. So it is generally used for the right side, unlike the Z and the T distribution. So if this area is alpha over 2, this one will be called chi-square alpha. So now we are going to learn how to find this value. If this area is alpha over 2, because we are dealing with the right tail of, sorry. So chi-square distribution You see that the left and the right are not of the same nature. So if this is alpha over 2, then the right side is a right distribution. Is skewed to the right, I'm sorry. So this is will be chi square 1 minus alpha over 2. Because the right side for the left tail of alpha over 2 is 1 minus alpha over 2. And this area will be chi square alpha over 2. If C is a confidence level, alpha is equal to 1 minus C. If degree of freedom equals to n minus 1. This degree of freedom is when we are dealing with the variance and the standard deviation. So let's start with the practice of how to read these two numbers that will become important. We are going to call them chi-square right and chi-square left to make it easier. So let's go back to the PowerPoint. So this is an image of degrees of freedom of a chi-square distribution. Before we come back to do an example of confidence interval for chi-square, I want us to practice reading the chi-square. Find a chi-square right and chi-square left for a 90% confidence interval when n equals to 25. So we are going to go to the chi-square distribution table. You have this table at the back of your book. Chi-square distribution, if you have your textbook, it's good to use it. Some of you have the formula sheet in it. So towards the end of your book, you will see the chi-square distribution table. The chi-square distribution table is after the T table. So you will see the first up here. These are the alpha. So use, this was not a very nice way of giving this example, but use 0.95 and 0.05 to find, look at here. Find the chi-square right and chi-square left for 90%. So for 90%, you are going to follow this table. I will explain it first, and then we will go back to the writing, on the whiteboard, so that we work on how to get it. So for alpha, in this example, you want, let me write it on the board. C equal to C equals to 90%. What will be alpha? This is 0.9. What is alpha? 1 minus C, which is 21. N equals to 25. 5 chi-square left and chi-square right. I'm writing here because you might want to come back to view. I always put this when I record it on Canvas. So we are saying here that C equals to 0.9, alpha equals to 0.1, N equals to 25. So alpha over 2 will be what? If alpha equals to 0.1, what is alpha over 2? 0.05. And what is 1 minus alpha over 2? 0.95. This is the first step. Hope we can all do this. So the value we are having here are the right sides of chi-square. So we will call this one chi-square right, or chi-square, I like using chi-square alpha over 2. And here we will call this chi-square left. This is alpha over 2. But we want to understand that the area is to the right. So looking at that table, what is chi-square right? For those of you with the distribution, chi-square left. I will show the portion of the table that you are looking at. So you look at the alpha, which is here, is 0.05, and the degree of freedom is 24 because n was 25. So if you have this, the chi-square right is 36.415, and the chi-square left is 13.848. So if you can read chi-square left and chi-square right, then you can find the confidence interval for variance and standard deviation. So the confidence interval for variance is n minus 1 s square over chi-square right less than or equal to sigma square less than or equal to n minus 1 s square chi-square left. And for standard deviation, you take the square root. Or n minus 1 s square over chi-square right sigma for standard deviation. We are going to take the square roots. what you do is after finding the confidence interval for the variance, just take the square root of the two numbers to get the confidence interval for the standard deviation. Now let's do an example. Find the 95% confidence interval for the variance and standard deviation of the nicotine content of cigarette manufactured if a sample of 20 cigarettes has a standard deviation of 1.6 milli. So here we have C equal to 0.95. N equals to what? N equals to 20. So degree of freedom equals to 20. What will be alpha? 0.05. Alpha over 2, 0.025. And 1 minus alpha over 2, 0.975. We are going to look at the table. Some of you with the table, can you look at the table? To find the chi-square right and the chi-square left. I want to show how you can use the Excel. To use Excel, you type here chi-square. You can find the letters. You could just type chi-square there. I am not, because I folded this I cannot find it. Anyway, I don't think anyone wants to use Excel, but if you want to use Excel, type chi-square and you will get. So let's come back to our PowerPoint. Anyone has the chi-square? Have you been able to find the chi-square right from your table? What is chi-square right? So in this example, C equal to 0.95, to 20, degree of freedom equals to 19, 0.05, alpha over 2.025, 1 minus alpha over 2.97. So the chi-square, right, is what? 32.85. Is that right? And the chi-square left? 8. You should be able to read this from your table. So the confidence interval will be n minus 1, which is 19, times s squared. What was s here? 1.6. The standard deviation of was 1.6. N is 1.6. I'm sorry, S is 1.6. So we are going to do here 1.6 square over 32.852. So we have 1.5 less than or equals to 5.5. 1.5 and 5.5. 1.5. Then we take square root of both sides. Square root of 1.5. We find the confidence interval for the standard deviation. So this is what I was saying about using Excel. We type here chi, and you see chi-square distribution right. You click on it. What we want here is the inverse, actually. We will have chi distribution, inverse right tail. So the probability is what is at the right, 0.025. The degree of freedom is 19. And we will have the chi-square right. To find the chi-square left, if you have understood how I was getting those area, then you can use this one. We are using the inverse for the right. This is chi-square inverse right tail. 0.975, degree of freedom 19, and we will have the chi-square left. So using Excel is an option, but just be careful. You are looking for the chi-square right tail so that you don't mix it. Let's look at another example. Find a 90% confidence interval for the variance and standard deviation for the price in dollars of an adult single-day sky lift ticket. The data represent a selected sample of nationwide sky results. Assume the variable is normally distributed. That is one of the conditions that enable us to use the chi-square distribution. The variable has to be normally distributed. So we can use our calculator to find the variance to be 28.2. That is if you are having a TI-83 calculator or you are using Excel. We can use Excel to find the sample variance. $59, $54, $53, $52, $51, $39, $49, $46, $49, $48. So we have these values and we want to find the confidence interval, the 90% confidence interval. So I might not have data here. Even with this, sometimes the data analysis is not going to come out. I need to start my computer over. Anyway, so you can use Excel to find the standard deviation. Or use your calculator as we did. I don't generally give you let's not spend time on this. You can. So let's go back to, you have S and you have confidence level. S squared is 28.2. What is the sample size here? What is the sample size? 10. The degree of freedom? 9. C, 0.9. Alpha, 0.1. Alpha over 2, 0.05. 1 minus alpha over 2, 0.95. So first thing is to find chi-square, right? And chi-square. Use your table or use Excel. You can either use your table or you use Excel. I'm going to use Excel here. To use Excel, type equal to chi-square inverse right tail. Chi-square inverse right tail. So I will 1.05, 0.05. And the degree of freedom is 9. So you will have 16 equals to chi-square inverse 0.959. 3.325. So the confidence interval will be, remember, n minus 1, s square over chi square right, less than sigma square less than n minus 1, s square over chi square left. So n minus 1 is 9. S square is already given to us. This is s squared, so you don't need to square it. So this is 28 divided by 16 plus 92. 9 times 28.2. I'm saying again that we don't need to square it because it was already a radius, s squared.
Why did you do that on TIA?
No, you don't have that test, that for chi squared. But we could do for mean, but you were not using it when we were doing it for the mean. Were you? Confidence interval for mean. This one is even much easier than the one from the mean. So I don't want you to get mixed up with so many distributions. That's why I just did not show you how to do it. But if you want to do it, you will have to go to start and choose the right test. So there you will see a lot of tests, and you will have to decide which test you want to use and enter the information. If you want to learn how to use your calculator, we can do it maybe after the class. So you can do this computation to find it. So the practice is first how to find chi-square left and chi-square right. You have homework to practice that. Then fit it into this formula. So this is the end of chapter 7. And maybe the end of my laptop. This is the end of chapter 7. So we will have exam next week on Tuesday, right? When is our exam? Tuesday. So on Thursday, I'm going to send you tonight, I'm going to send you a preview exam, a sample of the exam, how the questions are going to be. And you are going to work on it. If you want it graded, submit it before class. If you submit it after class, I will not grade it. As I said, if you don't do it, you are not penalized. If you do it well, we will count it. If what you have done is not very good, you just drop it. That's for the preview. We start chapter 8 on Thursday.